Chapter 18, air pollution. Now we're on control methods. Um, no, good spot to put it. Okay. Air pollution control. So automobile bill, it's two of two. There was a one. Oh, there we go. Okay, one of two. Um, Air quality standards. There was the Clean Air Act in 1970, and it was designed to protect public health, clear the visible pollution in the air, and prevent damage to crops. And how we do that is we trap or scrub emissions, and we use conversion techniques that reduce the of harmful compounds to less harmful ones. So we create a chemical reaction that takes it and turns it into something else. Here's a graph showing the number of bad air days according to the air quality index. If it was over 100, I think, um, number of days over 100. Um, Automobile emissions. Strong legislation uh, creates the EPA. I'm not sure about creates, was created by the EPA, I think it's supposed to be, with the goal to reduce automobile emissions. Limited success achieved by requiring the use of catalytic converters in new cars and increased fuel economy standards for all new cars. So catalytic converters help the combustion be more effective. So you get less carbon monoxide and more carbon dioxide. And then here's a graph showing the fuel efficiency has definitely improved, which is good, and it's better for our wallets to have a higher mile per gallon vehicle. Cost and effects, it has increased abatement and controlled cost while limited areas of the success have occurred. So like this is definitely a success, but it's still a challenge. And then something else we can do is carbon capture and storage, CCS, which is where we trap the carbon containing emissions or filtering CO2 from the atmosphere and then isolating the carbon in the reservoir. I didn't actually know we could like filter the CO2 from the atmosphere, but I guess now we have the technology to do that. That's very impressive. We didn't have that, I don't know, 20 years ago. Um, Also known as carbon sequestration. Here are some examples: carbon sinks, which are natural um, places in the earth that take in carbon, like extra trees, forests, or carbon sinks. Ocean fertilization, taking advantage of ocean critters or plants like algae that would use CO2. And while this sounds like a nice concept, it is like we already learned about too much algae. You can get the toxic algal blooms, as well as those dead zones where you're using up all the oxygen and getting the anaerobic decomposition. And so we don't want that either. We can dissolve the CO2 in oceans, but then we're going to increase the acidity of the oceans, and then that will probably dissolve the little shells of the seashells and everything, and not just seashells, but like those like microorganisms that are so important, uh, like the diatoms and little things like that we want in the ocean, and foraminifera, stuff like that. Pumping CO2 into coal seams and oil reservoirs. This is something we can and have been doing. If you use it for EOR, enhanced oil recovery techniques, like we talked about, you can use water, steam, carbon dioxide, then you're actually using it for an economic purpose. Otherwise, if you're just going to find a reservoir or you can do the same thing in coal seams and help get that coal methane out. Um, if you're just going to put it into a reservoir, that's very expensive. And if there isn't that economic gain, um, who pays for that? Um, here's a diagram showing, some carbon sequestration going into some of these reservoirs. The textbook said we have quite a bit of geologic reservoirs for this. So that's interesting. I do hope that that's true because I know there's a lot of uncertainty in doing this too. A lot of these reservoirs have to be pretty impermeable, not fractured or anything. Otherwise, it's just going to leak back out. And there is also the concern, just like with the oceans, about changing the chemistry in these reservoirs too. Specifically, if you're in like a carbon and like a limestone kind of reservoir, then same thing, you're going to just increase the dissolution of that limestone. And that's it for air pollution.